Promised you. And this one's pretty interesting, I think, because drones are hot technology, and I know these guys are going to be talking about that in the context of IoT. So without taking their topic for them, I'll let them come up and do it. I'd like to invite up Greg BVLOS from AT&T and Paul Gukian from Qualcomm. Gentlemen. Greg, good luck. Thank you, Paul.
Good morning. I'm Greg BVLOS from the Internet of Things organization at AT&T. My career actually started a short 28 years ago, about 3 blocks away from this very spot, with a small company headed by visionaries Chuck Geschke and John Warnock, really the start of the digital publishing revolution. And the reason I bring that up is we're at the very early stages in drone connectivity. And a lot of the challenges we had back at Adobe when I first started 28 years ago are similar today. What's the right partnerships? What are the right technologies? And how are we going to scale these from everywhere from consumer to high-end commercial vertical applications? Our little safe harbor statement, which basically means, unlike the debate on Monday, you cannot fact check me. All right, so what's our play here? You see some very large numbers on the left side in terms of the total addressable market. You'll see all sorts of studies that play into really how big this market can be. Our play is really what is the foundation we need to build, certainly on the technology side. Who are the ecosystem partners and what sort of ecosystem we want to build? And then how do we take that combination of technology and ecosystem and marry it back to the customers? Most of these verticals are AT&T's customers today. We serve really all of these verticals and pretty much every vertical you can think of in the enterprise space. But this is how we're thinking about the market. What do we do? Who do we do it with? And what are the solutions we're going to bring to market? Certainly, a number of enablements, enablers to get us there. There are components. So you see this big wheel here with all sorts of ways that AT&T can play in terms of drone connectivity. There are multiple challenges across not only the technology side, but also the regulatory side. Things like privacy, things like unique identification management, et cetera. We're also going to build on AT&T's IoT DNA. As of Q2 2016, we've actually connected over 29 million devices. See, these are not cell phones. These are just everything from cars to connected cities. We're playing both here in the US and worldwide. In the car space, almost 10 million vehicles as of Q2. We have platform tools, M2X and Flow. These are data management and rapid application development platforms. We have a global SIM, so you can stick a single SIM in a worldwide IoT product like a car or a drone and activate and manage that SIM locally in markets around the world. We certainly have our own internal use cases, which I'll discuss in a sec, and also really a lot of collaboration, not only with industry partners like Qualcomm, but also the governmental agencies, be it the FAA, FCC, NASA, et cetera. So what are we doing right now, right today? So on the left side of this slide, you see really our internal use cases. We are using drones for cell tower inspection today. We've announced, I think, 5 or 6 partners at this point. Just recently, in the past week, we did a study at Husky Stadium up in Washington, really doing a very detailed RF analysis of cell coverage within the stadium using a drone. There are also some potential future use cases within our technology operation side. Some of you are familiar with a cell on wheels, really a van cell site that you might use for events. Well, imagine putting that up in the sky. So now your cow becomes a flying cow. On the right side, Internet of Things Solutions Group, that's our organization. And we're really focused on how to build a business off of this. So we talked about the foundation, the enablements that'll get us there. We are enabling some partners today. There's a company called Skycatch in San Francisco. We announced back at CTIA 2 weeks ago, is addressing the construction management side of the construction management vertical. They have a full suite of tools that uses a drone to actually take daily surveys of a construction site, that can do volumetric measurements, and then using LTE connected tablets, get that data back organized and back to central processing centers. They're working worldwide. Their biggest customer is actually Komatsu in Japan. And then we're certainly, as I said, working to prepare and serve all the different verticals that we already serve with all of AT&T's existing solutions. So what are we doing with Qualcomm? Paul's going to get into some details on this, but really the focus is looking at today's commercial network at altitude and across a wide variety of parameters. These are infrastructure parameters, LTE bands, static flight, dynamic flight, handoffs, et cetera. We have the best and brightest minds at AT&T and Qualcomm addressing this. Subject matter experts are looking at the large amount of information that we're collecting in real-time studies. We're collecting data right from the drones themselves. We call that the UE, the user equipment. We're also collecting data from AT&T's live commercial towers that are addressed by that same connectivity. And then we're taking that data, consolidating it, and also running simulations. So if we're flying 1 or 2 drones at a time, how can we extrapolate that out into 100 drones in the sky? The whole goal is really to produce safer, cost-effective, certified solutions on our network, the network of today and the 5G networks of tomorrow, really all in support of enabling those enterprise vertical solutions. And as I turn things over to Paul here, I'll leave you with some innovation opportunities. We are still looking for partnerships, particularly in security, traffic management. That's an area we're working very closely with NASA. NASA Ames right here is leading the effort with the FAA on drone traffic management. Fog and edge computing, certainly there are limitations in the network of today of how much data you can upload, what the bandwidth is, so we're looking for as much to be done on the drone itself. And then the vehicle-to-vehicle communication challenges. How does a vehicle talk to another vehicle for collision avoidance, et cetera? So those, you get into unlicensed spectrum issues, certainly 802 and other frequencies can be used. Another one is DSRC, which is coming forward in the automotive world for vehicle-to-vehicle communications. How can DSRC be used in the drone world? So I'll turn things over to Paul. Thank you very much.
Everyone, I'm going to go right into it and really just summarize what are the objectives of the trial. We have our AT&T partner, very good partnership to really accelerate a lot of the use cases that are being promoted for the drone community. So we are looking near term, how reliable, how efficient is the LTE 4G network today in supporting drones up to this 400 feet altitude. So we're going to do a lot of, we are doing a lot of testing, over 500 flights already, where the network engineers on AT&T side are looking at logs on the cells, and we're collecting a lot of logs on the drones, and in some cases, multiple drones. And as Greg mentioned, all of this data is going to be looked at to validate simulations. And from there, we can really expand looking at urban jungle environments, New York City, how good is the connectivity, how reliable is it in those type of environments. The second thing is, of course, today's, the FAA has regulations that limits a lot of the use cases, particularly beyond line of sight, where we see connectivity, cellular connectivity is a key enabler. And so we're going to be putting a lot of technical contributions into the FAA rulemaking proceedings and working with other partners such as NASA, who are looking at traffic management for the drones in particular. And then third thing, 5G is not that far away, so everything we learn from the 4G will be leveraged into 5G, and that's really where you think about the future is going to have a lot of drones, a lot of new interesting use cases that are more mission critical that we need to look at some new features in the network. When we think about drones, the platform, we're not moving too far from our core. So a lot of the technology that we're using in cell phones today, especially the connectivity part, can be leveraged into the drone platform, but then some new opportunities. The summary here is a connected drone with autonomous capability really goes to safe introduction of the UAS, especially when you talk about some of these more controlled airspace environments where the use cases are going to deploy. The other aspect of safety, of course, and we're leveraging here, is high integration. How do you get a lot of functionality, connectivity, plus sense, and avoid precise precision, all of that into a small form factor that enables what's called the micro UAS. A lot of discussion on that with the regulators. And there you can see, when you have leadership in integration, we're building on our Snapdragon platform to create these lightweight drones, which are low impact and therefore low risk to both other airspace users and people and property on the ground. So finally, I want to go into a video, take you inside the UAS Flight Center at Qualcomm, which is somewhat unique, and I'm going to talk about some of those aspects. So if you could roll the video, please. So one of the things, it is an FAA-authorized site. It's co-located with our R&D. All of our resources are there. All of our engineers are there.
Miramax Tower, 5775 Delta.
It is in controlled airspace, Class B, and so we have a lot of protocols that we have to use, and you just heard there, one of them is air traffic control. What you're seeing now is real data that we've superimposed on the video showing what does the drone see when it climbs from the ground to 400 feet. And there's really one of these myths that antennas point down and don't service drones in the air very well. But you can see here at 400 feet, these are very good cell signals coming from 18 different cell sites with very good signal quality that the drone is seeing. And as we pan here from a first-person view from the drone, you'll see that these cell sites are multiple miles away. And that really tells you that propagation, the signal, the RF signal, moves very well to be received by the drone. Other thing I want to highlight here, again, part of the unique aspects of the flight center, it's in Sorrento Valley. It's 3 miles from Miramar Air Station, which is why it's controlled and restricted. But we have a very complex environment of commercial buildings, clusters of tall buildings, residential, and canyon. What we're looking at now is the second departure flight area, which is the top of our headquarters, 165 feet up on a helipad. From there, we're able to do flights, wide area flights, 1 to 2 mile flights, and look at mobility. How does the drone behave compared to a phone on the ground? So when you're on the ground and you're driving around or walking around, your phone is handing off to different base stations. We wanted to see what is the behavior of the drone at 400 feet. Is it comparable? Are there some optimizations that need to be done on the drone or on the network itself to make that more efficient, more effective, more reliable? And so you can see the drone transitions to multiple base station. Shots of Miramar. We have a lot of helicopter activity, which is why we're in this controlled space. I think San Diego is becoming one of these cities that has a lot of restrictions because of the airport downtown and the military airspace stations. And so it's really become this showcase environment to go and look at all of the challenges in probably what is the most complex airspace for which you need command and control. These drones, you need to know where they are, and that's why we're leveraging a lot of that cellular technology to really inform traffic management. Thank you very much.
Drones to measure the network and be able to do XYZ axis measurement of network signal, or is it drones that use the network and you're proving the point that they can get great signals?
So ultimately, it's for drones to use the network. Today, the regulations are data-driven, so we're actually gathering a lot of data that can be mapped to how were the networks designed and why do you have this reliable connectivity.
Yep.
Again, I mentioned it's a bit of a myth buster. We really want to show that with data.
Yep.
They're well served at altitude up to 400 feet.
Do you have any idea about the upper limits of that then? Like how high could you go and get good cellular strength?
It's interesting, we saw some, and then very preliminary, but going from 300 to 400 feet,
yeah.
As you see more base stations, you actually start to see some of those signal quality degrading.
Yeah.
So there's this interference picture. The more you see, the more they become interferers.
Right.
So 400 feet, certainly very well served. 500 feet, I think we're going to see some degradation occurring.
Yeah, I guess what we do in the cellular network is frequency reuse. So often you'll have a cell 5 miles away using a frequency that you use again 5 miles down the way. One of the problems you have with airplanes, people in airplanes using cell phones, is they're touching too many towers. So you see 400, 500 is safe, and then a risk of interfering with the networks as you go higher?
We're not, I kind of have this, there's this description that drones get up and they confuse the network.
Yeah.
It's like, I think, the lion amongst the zebras, right? Just running around trying to pick one. That's not the case in the testing that we've seen so far. But we are looking with AT&T at what is the network C that could potentially be interference limiting?
So from AT&T's perspective, do you see potentially the fleets of drones that are serving industrial uses, agricultural uses, all able to fly using AT&T network connectivity? Is there like a service or a farmer who's going to deploy a fleet of drones up and do some kind of sensing and measurements and be able to manage them all semi-autonomously by connection through the network?
I think you're going to see the full range from the small farmer who actually might own his own drone and do flights, but might rely on a service to actually analyze the data. Conversely, there's companies that are looking into fleet management and almost franchising drone as a service, certifying operators across the country to certain skill and safety levels, and want to deploy that across all different verticals.
Right, because I mean, I worked with an organization called AUVSI, and they're basically the drone industry organization. And in working with them, I saw all kinds of great uses. In agriculture was huge, but like you said, there's all kinds of small businesses popping up who are saying, well, I'm going to fly a fleet of drones, and they're talking about crop dusting. The coolest thing I heard was painting, and interesting for San Diego people, ship painting. And it's very difficult to paint a ship that's in the water, but they need a lot of coats of paint because of the salt. And so you get these, barge goes up alongside, and it's moving platforms. And they said, well, if you paint with a drone, you can program it, and you can actually apply less paint if you get drone precision. And then you go, yeah, but how do you carry the paint? They go, well, we're going to tether a tube for the paint and tether two wires for the batteries. So you take the batteries out, and you have ample power if you tether wires. So we can work up to about 300 feet of altitude pulling those tubes up. So you can see a fleet of drones potentially being programmed and managed, and you're arguing that that might be a cloud-based application that uses the network.
Right, and you mentioned another particular area for innovation, which is precision location.
Yep.
So if you're going to be using a drone to paint something precisely like that, you need to do very precise location. So there's, there's folks focused just on that particular problem.
That's true, and to get highly precise location, you need incredibly precise time measurement, right? To get the offsets, and you do GPS correction using terrestrial-based signals, and so the network could play a role in getting that centimeter accuracy levels. It's pretty interesting. It's in a certain sense, we always have client-server in the concept of things swinging to the edge and then back to the center. And I guess if we're talking about connected drones, you're proposing that a lot of the intelligence can be swung back to the cloud, essentially, in the drone world. And from a consumer's perspective, we're very much so far conditioned to think of drones as standalone products. But I guess there's a long history of the military and other people thinking of drones as parts of complex adaptive systems or systems of multiple drones and aerial vehicles. So are you guys thinking more along the lines of systems and multiples? You mentioned you're also thinking ones and twos, service providers and ag and stuff, but are you thinking a lot about multiple aerial vehicles going up? When you mentioned the cow example, cell on wheels, now on propellers, is that what you're looking at?
Well, I think from the compute perspective, and Paul can answer this, companies like Qualcomm are innovators in terms of being able to do and to bring high levels of compute power, very low cost and high efficiency, not requiring a lot of battery life, but actually enabling the ability to do real-time processing right on the drone. And that's what we're going to need and see.
So it's a bit of both, and cloud and processing on the drone. And of course, if the drone gets disconnected from the network, it's got to have adequate intelligence to manage itself down safely and such. A lot of safety protocols. Let's talk about that flying cows, because first of all, flying cows is the kind of thing, but here's an acronym I can finally see the consumer press picking up and thinking is interesting. But also, very cool, because even when you say, okay, Santa Clara Stadium's going to have, Levi Stadium going to have the 49ers play there, you're going to maybe roll in some cows to handle it. Some future vision, Burning Man or something like Levi Stadium, you can envision using cows to handle the surge in demand. But the coolest thing about it, I think, is that you can plan in advance where you think the crowds are going to be, but a matrix of cows is very flexible, right? So if a crowd develops around an impromptu show or concert, or a guy beating on some drums, you could just shift those cows left, shift them east or west to handle the traffic, right?
So the whole dynamic nature of that really can be applied to things like disaster recovery.
Yeah.
Where you have a totally unpredictable situation. So maybe we prove out the technology in more fixed locations like stadiums or the Coachellas of the world. But where we really want to be able to apply them is those unpredictable situations where you need really coverage on demand.
It's interesting. I mean, looking back at Hurricane Katrina, I think it was one of the things that was interesting where a lot of the regulations and slowdown elements of deploying cellular networks were off the table for an amount of time. If you can get connectivity, if you can get power in, do it any way possible. And that ended up being an interesting proving ground for a lot of technologies like this. Although I think to your point, you want to test them in predictable Coachella events so that you're ready when that disaster comes. But yeah, and so what do you envision is the uptime for something, a flying cow, and then it comes down and trades off? Or?
Oh. Do you have some thoughts on that?
I mean, I was going to say, deployable base stations for emergency recovery on the ground has been very effective. I think, drones are being looked at now because of the evolution of small cell technology, where you can actually put the small cell in the drone, and now you have a coverage area for command and control that can be deployed right away versus deployable base stations that only get you part of the way. So it is an interesting area. It's already being explored with disaster recovery teams by actually partners of ours to see how effective is a small cell and what kind of coverage can you get. And then, of course, how good is the network if we use drones as part of a disaster recovery where command and control is from a deployed drone that's using, base station, which is controlling multiple drones for disaster, for recovery. So
it's actually looking at a bit of a hybrid approach of still working with the ground-based stations, cheaper, run with a generator, et cetera. And then they're partnered with some aerial coverage as well. Pretty cool. Let me ask one more question of Qualcomm and then one of AT&T. So you mentioned that you guys have a platform that you showed us the circuit board. I think you have it on display out in the hall too, so we can have a quick look at it. And the central hall, you can look at that one. So this gives the ability for all kinds of new entrants to maybe design a drone around your platform and get all that functionality in one PCB, right?
Yes, that's correct. Cool. Yeah, so a Snapdragon platform. So again, all these kind of features for detect and avoid. You can imagine that there's different classes of drones depending on what they're doing. So if they're out doing agriculture type events versus delivering packages to the inner city, the capability of the drone has to go up, and it can go up by adding more and more weight, because then it kind of counters the safety aspect.
You're proposing adding software or turning on functionalities?
And adding small sensors.
Great. And then, Greg, you mentioned AT&T providing global SIMs. So it's like, getting off drones a bit, been back into IoT. So AT&T is providing global SIMs, and I guess the goal would be to give it to equipment makers like a Lenovo or like a Ford with the concept of simplify, just put this in as your radio unit, and you can land that car and sell it in the Netherlands or in the US or in Canada, and it will connect to an appropriate network?
Right, and today we're powered by the Cisco Jasper platform. I think they're speaking on the other stage right now on this very subject. So yeah, a big automotive manufacturer or drone manufacturer can put a single SIM in there and use the Jasper platform to activate that using local rates and local carriers. We have over 200 carriers around the world.
Because that's basically the follow-up question is, okay, great, I have a Ford car selling in the Netherlands. It's got an AT&T global SIM, and that's going to give me worse rates as a customer in the Netherlands because it's not KPN or a local carrier. But you're saying that you guys, through Jasper partnership, have pre-negotiated local rates for those cars?
Correct.
Awesome. Yes. Good. All right. Well, I checked. We got nothing on the mics. So with that, gentlemen, thank you very much.
Thank you.
All right.
Thank you.